All right, so if we have 20 seconds, the 20 oscillations here, um, Tomlinson and Brianna, and we have a time of 24 seconds, right? Um, it, how much time will it take to complete one? So we have 20 oscillations and it takes 24 seconds to complete all the 20. How much time would it take? I just need Tomlinson and Brianna to answer that. You want to give it a shot or
Can I say how many time it would take to complete one oscillation?
right? So it takes 24 to complete 20. So how much time would it take to complete one? What would you do here?
Sir, we
Alright.
divide.
All right, we will divide, right? So we're getting somewhere. So there's some kind of division involved, and our time for one oscillation is referred to as a period, and the sign for period is the big T, as you can see here, the big T. So big T equal. Now what are we dividing now?
Sir, 24.9 by 20.
24.9.49 by 20, right? Are we seeing that, Brianna?
Yes, sir.
Right, so 24.49 divided by 20. Right, so what is our answer here?
1.22.
1.2.
1.22. So we would do the same thing for the rest of the numbers here. So it would be 30 divided by 20, 34 divided by 20, and then you will see that the time increases with the length of the pendulum, right? So you have 1.22. You probably want to take a picture of this before we move on, right? So now we move on now to the period squared, and this is essentially what? What is this? How do we calculate the
Sir,
period
the answer
squared?
time pixel.
Right. So we can. So what were you not understanding? All right. Let me see that we're good here. So 1.22 squared. What is our value for that?
1.48.
1.48. So are we good now? We have a better understanding.
Yes, sir.
All right. Somebody has a calculation of the gradient. Who was that person again? Not, I don't remember.
Me, sir.
All
Rena
right.
again.
Okay, no problem. So we have, say we plotted our graph, and I know we're not able to go through the whole pattern of graph. I'm not able to sit with you and work out if this point is correct, but you have my number, and I try my best. After 5 o'clock, I put down my phone, yeah, because I'm tired. But I will take it up back at some point, and I will see the message. And if I see that you plotted a graph, I am going to be attracted to that. I'm going to look at it. I have to look at it, right? So if you plot a graph, if I see a message, right, that you plot a graph and you want me to see how it looks, right? If you attempted to use these values here, right, these values that you filled out, when you plotted a graph, I am going to look at it and I'm going to give you feedback. Some persons in the class would have already done that from a week and a half ago, and they have completed their assignment and they have a better understanding moving into the monthly test, right? So I encourage you, right? Um you have my number. Reach out to me, and well, you won't be required to plot a graph on the test. It's multiple choice, but some of the concepts will come out. All right. So the gradient. Let's just do this quickly. Now you see a line here. You see a line here on this line. I believe this works easier, right? I'll just show you in a second. So this we are comparing. I hope this explanation. I didn't do this explanation at first, but I did some reading on it how to actually explain the gradient a little bit better, and I hope this works. Right? This is considered our rise, right? Our rise.
Or what's it?
Rise. I place it here. Rise. I'm just add these persons. So I didn't explain it so good as I would intend to. So I want to do that now. Hopefully it will help a little bit better. So this section here, this line here is our rise, and this line here is our run, right? You probably would have seen this in mathematics, or if you watch any videos on YouTube. So you want to find how much the graph has risen by. So you want to find out this value here, this guy here. You want to find out the value of this guy, and you want to find out how much the graph has run by, right? How has it moved, right? What's the extent of its moving, right? So it's running this direction, right? And it has run by from 0.4, we see here, from the original 0.4, that started from 0.4, and it has moved to what? What is this value here? What is that value?
So is it 0.9? Because I can't see it
Yeah,
clearly.
so we have 0.9 here and we have 1. So what is in the middle?
0.95.
Right, so in the middle we have 0.95, right? So it has moved from 0.4 to 0.95. Now over to a gradient. M is equal to what goes up here again? Anybody remembers?
I don't know.
You don't know? You did read over your notes, right? So we have y2. Let me just help you. Y2, and what goes here?
Y1.
Y1 over what goes on here now?
X2.
X2 minus X1, right? So this is the same thing as rise over run. You can see that, right? We can see that this is essentially the same thing as rise over run. Rise in this direction and run in this direction, in our x direction. So probably this will help a little bit better. You want to find the difference in the movement of the graph over the range of values, and you want to find the difference in the movement of the graph horizontally in the range of values. All right, so we got x2 and x1. We see that x2 is what again? What is our x2?
Abigail, on your assistant help you throughout your day. Saying to get started.
You can send a message in the chat. What is our x2 again? No. This guy right here, right?
Very good at that, like times
0.95.
Right. So 0.95 is our x2. And what is our x1?
0.4.
Right. So minus 0.4. Right. All right. So for our rise now, we want to calculate. We want to get our y2. What is our y2?
We can answer that clearly.
This value right here, right?
Yes, sir.
But
All right. So it is from my screen. It is 4. Right. From my screen, it is 4 minus. So what is our value down here? Right. This is 2 right here. So and this is 1.
but
So,
1.5.
1.6 or 7, somewhere there, because
right.
it was.
So 1.7, we're getting close. So this is 1.5. We have 1 here and we have 2 here. In the middle is our 1.5, right? Middle of 1 and 2 is 1.5. And this value goes to that, right? So between 1.5 and 2, what is our value between 1.5 and 2? What is our value there? Between
1.6 is
Almost 1.7.
1.7, 7 what? About 7.5, right?
So
Yeah, 1.75. So somebody else take out their calculators and just work through this again, right? 1.75. So what are we getting for the rise? What is our value for the rise? So 4 minus 1.75, what are we getting?
2.25.
2.25 over, what are we getting here?
0.55.
0.55. So are we understanding a little better now? Right, I'll try and do
Yes,
Hooke's law
sir.
quickly. Right, so let's see how quickly we can move. All right, what is our value here? 2.25 over 0.55.
0.09.
4.09. All right, so Mr. Treasure is going to give you a formula now to calculate the acceleration due to gravity from this value here, right? You'll see this on your test, right? So pay keen attention. Our formula that I will give you is G, which means gravity, right? Or acceleration due to gravity. I'm sorry, the computer is moving a little slower, so I don't know why. Sometimes it behaves like this. 4 pi squared over m, right? So this is our formula to calculate the acceleration due to gravity. And what is m again? What is m?
Sorry, the
Mass.
gradient.
All right. So I heard the gradient and I heard the mass. So that you're correct with the m is mass, right? That's actually true. But for this particular question, the m in this case is the gradient, right? So we move on now and we will plug in our value. So G equal 4 pi m. So 4. So somebody square pi for me, please. What is the value for pi squared? So just go ahead and square pi. All right.
Sorry, 9.85.
Uh,
9.86.
9.8.
9.8. I'm just rub this out. Please, if you're not understanding, I'm not going back over this again. Right. So 9.86. Tell me, stop me, Mr. Treasure. So on, so on, so on. Right. So 9.86. And what is our value for m again?
4.09.
4.09. Right. Anybody remember the value for gravity? Right, we spoke about this in the past.
Sorry, 9.8.
9.8. Right. So somebody's reading over the notes. 9.8. Now let's calculate this. What is our value for G now? So we have 4 times 9.8. What are we getting here?
9.44.
36?
39.
Oh, 39.44. All right. Sorry, the computer is moving a little slow. All right. And our value is 4.09. So what is our final value for the acceleration due to gravity for this question?
9.64.
9.6. You want to check that again? That's what you're getting?
So 0.96.
All right, 0.96. All right, that sounds a little off as well. Let me just do a quick check here. All right, so I hear 0.6 coming out. All right, so our value, yes, is 0.64. All right, 9.64, right? So our value here is 9.64. I'm running out of time. Right? Our value here is 9.64. Now look on 9.64 compared to 9.8, right? You see that it's kind of close. It's not fully 9.8, but it's kind of close. So if you have any questions, please stop me. Are we understanding? Are we
Yes,
good?
sir.
In the chat, if you're shy and you don't want me to hear or you don't want the class, you can send it in the chat. No, sir, I am not good. All right. All right. So I'll stop sharing this and we move over quickly to Hooke's law. All right. Let's move over to Hooke's law quickly. All right. Somebody expert. Who was the person that was having trouble with Hooke's law again? Before we move over,
Yes, sir.
Tomlinson.
Yes, sir. It was
What?
breaking up a bit right there.
Oh, you were the person that was having trouble with Hooke's law.
Yes, sir.
Anybody else? All right. All right, Miss Van Horn. All right. Let's do it quickly. What aspect of Hooke's law we're not getting again? What part of Hooke's law are you not getting?
Sir, to use the formula to find it, sir.
All right. All right. So we'll do that in 20 minutes. In how much time we have left on this? 8 minutes, and then we'll go over to our. Yeah, I spoke to Miss Renika already. Thank you. All right. Let's do it quickly. Then we move over to. Why does this keep on showing up? Just want the regular. Keep on coming up. I'm sorry. Give me a second. Exit full screen. All right, no problem. Okay. Discard. Right. Oh, sure. All right, so let's see how fast I can move. Right. I am not doing this again, guys. All right. Because it's really the first time. I encourage you to go back over your notes after the class. Right. Immediately after the notes, we try to go over and get a better understanding. Please tell me if you're seeing this. Yes, sir. Okay, beautiful. All right. So let me get my pen here. All right. So remember that this is our formula: F equal kx. Right. The negative here means that it's in the negative y direction. So whenever we're pulling, let's say, a weight here, it's going down. So that's why we have a negative sign here, but it doesn't really matter, right? Okay. Whenever it's going down, a negative sign means that it's being pulled down. A negative sign means that it's being pulled down. The weight is pulled down, right? All right. So we understand force. We understand the spring constant and extension. Are we good with this formula here?
Yes, sir.
All right. So we can move on then to the working out. And we were saying that of the force, right? Weight, the weight that is pulled down, that pulls down a spring is essentially the force. right? It's essentially the force that pulls it down. Now, in order for us to calculate this weight, we have to use the force formula. You will learn about this in the next session after this 20 minutes is finished. After this session is finished, for the last 20 minutes, we'll try and cover it quickly. But you'll see this popping up again, right? Force equal mass times g, which is gravity or the acceleration due to gravity. Please remember this, right? So if we have a mass of say 300 grams, let's say we have a mass of 300 grams, how would we go about calculating the force or the weight? So we'll start out with force. So F equal, I hear somebody giving a shot. Right? Somebody was saying something. Mm. Yeah, so force is F equal, right? We're just repeating this guy here, mg. Now, what are we getting here? Miss Van Horn and Tomlinson, could you help me out a little better, please?
So first we change milligram to kilograms.
All right, so you change the grams. You change the grams to kilograms. Are we seeing that, Miss Van Horn and Tomlinson? Are we seeing that?
Yes, sir.
Yes,
Right.
sir.
So you change the grams to kilograms. Why? Why do we change it? Do you remember why we change it? Right, we change it because it's the SI unit, right? We do all calculations in physics in SI unit. I will try as best to do most of our calculations in SI unit, right? We can make some exceptions, but for this particular question, we want to keep this. So what is this converted to grams, right? We have kilograms, we have 300 grams. How do we move this to kilograms now? How do we move this to kilograms from 300? So 1,000 grams.
1,300.
So 1,000 grams equal how much kilograms?
One.
Right. So 1 kilogram. All right. So what do we put down here?
So the 300.
Right. The 300. So are we seeing that, Mr. Tomlinson?
Yes, sir.
Right. So we put the 300 down here. Are we seeing that, Miss Van Horn? Are we seeing that? Are we good so far? We're following.
Yes, sir.
All right, beautiful. So we put the grams where the grams are supposed to go, the grams over here and the kilograms over here. We want to find out how much kilograms. So we put X, right? And what we do next?
Divide.
So
Mm,
cross multiply.
Cross multiply.
right, cross multiply. So we cross multiply and we finally get, what do we get down here? For the 1,000 grams times X, what we have? Put on 1,000, right?
1000x.
1,000 X equals
300 gram.
300, right? And then we want to get X on one side to get how much the kilograms is. So what do we do next? We want to get rid of
So
this
we
guy, right?
divide both sides by 300.
We divide both sides, so we're on the right track.
So you divide both sides by 300.
No, we want to get rid of this
By
guy,
both sides by 1,000.
by 1,000, right? So we divide both sides by 1,000, and we get X equal what? What's our final answer here?
0.3.
0.3. 0.3 apples, 0.3,
Kilogram.
right? So 0.3 kilograms. So we